Okay, this is my second progress report on my particle system. So I completed the Markdown site, or at least most of it, using Zensicle, which is basically just like a Markdown site builder. So I made it so it automatically rebuilds whenever I push to GitHub. So if I make any changes and save them, it basically just rebuilds the site for me and deploys it. I also added a bunch of extra explanations and instructions for all the new things I added, or just reclarified certain things to make it easier for the students. And this includes adding visual and code examples. I also updated the OpenCL interop, add this thing called steps per frame, which launches multiple kernels per frame and automatically updates DT, which is like how far or how fast the particles move. And this is super important because this basically allows you to control how much time is spent actually computing the particles changing versus just like rendering the frames and everything, because it's a particle simulation, so you kind of want to make sure you just move the most particles at once instead of just pushing the highest frame rate possible. I also did some basic code refactoring, and I made sure the markdown code matched the source code. So again, the things I worked on was mainly refactoring, setting up Zensicle, and completing the write-up, which are all pushed to all the GitHubs. And basically the things coming up are going to be create an answer sheet, basically something for the graders to go over, like kind of solutions to all the problems, which is going to include creating a branch on a private repo with the codes, like code examples of like what a fully finished project with like all like the bumpers, like the correct like work group size and stuff would be set to. I need to test Linux compatibility, but again, that shouldn't be that hard. I'm going to have some of my friends like try to set up the project and at least get it running just to make sure they don't get any issues and make sure it works perfectly reasonably, like pretty easily for them and everything. And I also need to update the write up if they have any like complaints or whatever about it. One thing to keep in mind, there's a private repo right here, which is the one you've had before. The public repo is a little different. This is where the README is hosted, as well as I'm probably going to host like the base particle system stuff at code without the solution. And this is like a link that just goes to the README GitHub page from this. It just Beeves link, so. And then there's no blockers right now, so that should be all set. So if you look at the workflow, this Zensicle actually makes this all for you. I think I had to change like this where it uses like the exact location of something. Maybe it was this or something like that. But other than that, actually, I think I just changed this link and then it generates this whole thing for you. So just automatically you just place it right here in .github/workflows, and every time I push, it will automatically deploy it for me. Now, if we actually go to that site, this is, as you've probably seen, it's right over here. I tried to make it look very easy to understand. I tried to make the explanations like not super wordy, but enough so it's again easy for the students to understand, but also makes sense. It doesn't like leave out too much information. I use like drop downs like this to make sure you only have to see like what you want to see. Because again, if you're using this on Mac OS, you don't have to see like the Windows stuff, so there's no point in showing it to confuse them even more. This is the whole explanation about like the optimal steps per frame, which this is just a graph I kind of took from Mike Bailey. It's this one. It's just I added an extra steps per frame thing right over here, which kind of explains like what's happening when you change steps per frame, the value. This is just a big explanation about it all. I had a little bit down here as well. Um, that should be good for this, which I can show you in the code what it looks like. So all the students really have to do is they just change just one value, and that's all they do on their end. And then what that does is basically, instead of this just running once, it basically puts on a loop based on the steps per frame. Like that's all it does. But this makes it so you can focus more on actually computing stuff for the kernel instead of just only computing stuff per frame, which again, if you're getting like a lower frame rate or like have VSync enabled, you're going to move way less particles if you only have like 1 steps per frame versus like if you had 10 steps per frame or whatever. So again, that would be like moving the particles 10 times per frame instead of just once. And then this is all the same. Again, warnings look kind of cool. These are like links, so you can like jump down all the way to stuff down here if you want. If I go, or I can click on the side. Again, this is the whole Zensicle thing. There's a dark mode by default or light mode maybe depending on your computer. If I go back over here, it's explanations of like explaining the kernel, testing performance. For like the graphs, for instance, I actually made an example graph. But I also did a thing where if they don't want to do it through Excel, because I hated doing that, I figured out some code that lets you just like, go to this website right here, just copy and paste the code in, and you just change like this based on the results you got or whatever, and it generates this graph for you. And then the rest of this should be the same. And I broke down these explanations a little bit to make them a little bit clearer. This is like explaining the actual sample code, like how it all works together. This is explaining the kernel specifically. This is kind of important because it actually has like hints like this. Like this doesn't actually show in the code right now. This is just how to like read and get the colors, which will be helpful for the students if they actually pay attention to this part. And these are just like random troubleshooting things. I might add more in the future. But yeah, that should be it so far. It's going along pretty well.